On Leetcode, there was one question in particular which I regard as being the perfect problem. This problem is called TwoSum, and if you've been on the site at least once, you've more than likely seen it as one of the top answered questions. And in this video, I want to break down why I think it's the perfect problem to try and solve. It's one which, admittedly, isn't too difficult, it also isn't very easy at the same time. It's one that also has a fairly straightforward solution, but one which, when you submit it, it's not going to work, it doesn't actually pass all the tests. And that's because of how computationally inefficient it is. The solution that works well in linear time, I think, is genius. It teaches you an awful lot about Python, especially with dictionaries in particular, and about why brute forcing over things isn't a great idea. So through a fairly simple, straightforward problem, you learn an awful lot about coding and about efficiency in general in your code. So through this video, we're going to break down the problem. We're going to go through the brute force solution, and we'll then do a deep dive into the linear time solution as well. Just before we start, if you are wanting to learn Python, there are free courses linked down below. You've got my beginners course, my brand new object orientation course, and one all about functional programming of comprehensions. So, without further ado, let's jump into the TwoSum problem. Let's first go through the problem brief. We are given an array of integers called nums and an integer called target. What we need to do is return the indices of two numbers which add up to target. So say, for example, we take this one here, example 1. Our list contains 2, 7, 11, 15, and we're given a target of 9. So basically you want to find which two numbers here equal 9. In this case it's 2 and 7, but we don't return 2 and 7, we return their position. So in this case it's 0, 1. So we take this one here, 3, 2, 4, target of 6. It's going to be 2 plus 4 to make 6. There are indices 0, 1 and 2. So 1 and 2, you're going to want to return this here. Another caveat is that each array or each list is going to have exactly one solution, and we can't use the same element twice. And as of filming this video, so where are we today, 5th of December, it's had just shy of 60k likes and 1.1k comments. So very popular problem, and I think it's quite a simple one to understand kind of straight off the bat. Now the way Leetcode works, if I just expand it this way here, suppose you put in your solution here, and you go ahead and hit run. You may have tried it locally on your own machine and it might work with a couple of test cases, that's fine. But what Leetcode will do is it will have not just these 3 test cases here, it has a ton of test cases further down the line, and some of them are so big that if you do a brute force solution here, it times out and it fails. So it can work on your own machine, fine, if you leave it for long enough, but Leetcode is going to be a bit more pedantic and a bit stricter about how long it's going to take to run. So the next thing we'll do is we'll look at the brute force solution, we'll look at how it works, we'll then take a look at why it's bad, and in terms of its computational complexity or its runtime, we'll look at how as nums grows, the actual time it takes to run grows exponentially, whereas the perfect solution at the end grows in a linear fashion. So we'll jump into VS Code and we'll take a look at the brute force solution first. So what I've got, I have my numbers 2, 11, 7, 15 and a target of 9. So just kind of recap the problem again. Given that our target is 9, we require two numbers from this which equal 9. In this case it's going to be 2 and 7. We don't want to return 2 and 7, we want to return the indices they are at. So 2 is at index 0, 7 is at index 2, so we're going to want to return 0, 2. Now, the basics of doing this, if I kind of talk it through first, the brute force approach is to use a nested for loop. So if you imagine your outer loop's going to say, for each number in this, go through and do something. So let's kind of write this down here. So our outer loop, let's write the following. We're going to say, in fact, we'll do it on the same line. Go through all numbers. So we'll say this here. So our outer loop is going to go through all numbers. The inner loop is basically going to say go through all numbers again. So if you can kind of imagine what this would look like, if I just change that to an M, there we go. So the outer loop is going to start and say, okay, I'm at 2. So envision this starting at 2 here, okay? The inner loop is then going to go through the rest of the numbers. So whilst the outer loop has hold of 2, the inner loop is going to say, okay, I will look at 11, 7, 15, right? Okay, cool. We'll do some checks along the way, but let's imagine this keeps on going. Once this inner loop is finished, the outer loop moves to the next number. So in this case, we now go to 11, and we say, okay, now let's take a look at 7 and 15. So envision it as like 2 placeholders. One's going to say, okay, I'll keep hold of the 2. Something else can then go off and say, okay, does 2 and 11, 2 and 7, 2, 15, do any of those equal the target? Now, with this small list, the brute force solution's probably okay. I mean, just checking a list of size 4, yeah, nothing's going to really complain about doing that. The problem is how this scales up. So if you imagine that this was, say, like 10,000 things, the outer loop is going to look at the first item, and then the inner one is then going to check 9,999 things all the way to the end, move to the next one, now check 9,998 things. It just goes up kind of this massive kind of exponential scale. So as the size of our list grows, the amount of checks we have to do doesn't grow in linear proportion with this. It grows exponentially, and we can try and prove that actually. So let's remove this first, and we'll build this solution up from the ground up. Now, the most common way, in my view, that people tend to do this is by using a range function. So let's build our outer for loop first. We'll say for I in range, in this case it's going to simply be len of numbers here. Sorry if I can spell it correctly. There we go. For I in range, len of numbers. And let's print off, we'll do two things. We'll do print off I, and also print off numbers. Done it again, haven't I? There we go. Numbers of I, like this. So printing the index up front, we are then printing the item at that index from our numbers list. So if we hit run, there we go. Indices on the left, 0, 1, 2, 3. Items on the right, 2, 11, 7, 15 here. So this is my outer loop. Okay. Now what we need to do is build an inner loop inside this to basically say, okay, now we're at 2, go through the rest. Now there's a bit of a little bit of trickery involved in this one here, because we're not just going to say for j in range len numbers. We're going to basically start counting like from the position after 2 onwards. So to do this, we'll say for j in range, like this here, and then we'll do I plus 1, okay, but then we'll still do len of numbers at the end here. There we go, like this. Looks good. And let's take this out for the time being, and let's label this as our inner loop. There we are, just like that. Okay, now let's just print off our stuff inside it. So if I did, let's just do print ij. We'll build this up kind of gradually. Hopefully VS Code catches up with that. Yep, there we go. Took its time. Then let's run this. So we can see that this is now going through every index, or kind of every index pair, right? So 0, 1, 0, 2, 0, 3, 1, 2, 1, 3, 2, 3. Now, rather than just printing the index, let's print off the numbers at those indexes. So if I did numbers of I, and then did numbers of j just after it. So we should see the like 211, 27, 215, and so on. There we go. So 211, 27, 215, yeah, cool, that's how the first sweep done. Then whilst the outer loop is at 11, we're doing 11, 7, 11, 15. Once that's done, we then do 7, 15 here. So, you know, if this grew, say we had an 8 in here, we'll expect it to grow quite a lot. I mean, yeah, even the size of that, right? That was 1, 2, 3, 4, 5, 6 things printed off. Just adding that thing at the end, yeah, you can see it's grown not just by 1 extra check, it's grown by quite a few more. You know, if you had, just for, say, illustration's sake, yeah, doesn't grow in a kind of particularly nice way. So, yeah, there we go. Let's remove this back so it has its original numbers, and we'll clear the screen. So now that we have access to the numbers, we now need to do a check to basically say, okay, now do any of the pairs we're looking at, do they equal the target? And the way we do that, if I get rid of my print statement, but I'll keep these two within, we'll say if numbers I plus numbers j happens to be equal to the target, you know what, I'll just print them for the time being. So I'll take this again, and let's just do a comma, just to print off the numbers that we have. Yeah, there we go, 2 and 7. Let's say the target was, let's say 26, so we should get 11 and 15. Yeah, there we go, looks good. Let's suppose it was 18, so we should have these two, so that's fine, yeah, 11 and 7 looks good. So bear in mind, we're not actually asking for the numbers, we're asking for the indices. So what you could probably do in that case is then just do ij, like this here. We'll do run again. There we go. We get 1 and 2. Put us back to its original. We should expect to see 0, 2 now. Yeah, there we go. But what you want to do is return it as a list like this. Now, the only thing I've left out is on Leetcode, it gives you a function to put this in. Just for showing the concept, I'm not going to bother. Just kind of get into the meat of it like this, I think is absolutely fine. But if you are doing this in Leetcode, it'll basically ask you to pack this inside a function, and then whatever they've called numbers, it might be nums or something like that, you want to be iterating over that instead. So if you were to do this in Leetcode, the first few test cases are going to be fine. They'll pass with no issue. The problem is the really big test cases on Leetcode. It's doing this dual for loop situation. That's what gives you that kind of exponential time complexity, and that's what's going to make this fail. Even though the code is correct, the time it takes is simply too long. And I think this is one of the first really good things you kind of learn using Leetcode and kind of just about Python and coding in general, is that you can have working solutions which might work first time, but it does a lot in teaching you that the brute force solution isn't the best solution in a lot of cases. Sometimes it might be the only situation, and that's fine. Things like a linear search over a fixed list of numbers, that might be inevitable. But TwoSum is a problem where you can brute force it, but using the linear approach I'm going to teach next is a whole lot better. And it's something that won't just apply to TwoSum. You could take this kind of learning experience of saying the brute force one didn't work, but here's a linear one. It's a bit more sophisticated, requires a bit more techers and technique and a bit more thought. You can use that in so many situations. So learning this technique I'm going to show you next, I think is incredibly valuable. And I know when I did this first time, I thought I cracked it when I did this many years ago. And then, you get a bit shut down. And then you look at the dictionary solution and you're like, oh, okay, I've unlocked something here. This is great. So what I want to do really quickly is I'm going to change this to be a really large set of numbers. And when I'm going to count how many checks it's doing, and when I'm going to compare that to the dictionary version. Okay, now I want to show this in quite a crude way. Now, one of the things we do in computing, kind of more in algorithmics in general, is we're quite pessimistic. We consider what's called the worst case scenario. Okay, so if you imagine that you're trying to search for a given word in a book, we basically say the worst case scenario is the thing we're looking for is on the last page, it's the last paragraph in the last sentence. That gives us what's called an upper bound, so we can say the problem is at the very worst case scenario, the problem is as hard as the book is big, if that makes sense, right? If you imagine in this case here, if you're trying to search this list for, say, 1,000, we can say, I don't know, suppose this was 20 numbers long or whatever, we could say at the very worst case scenario, it will take 20 checks. 1, 2, 3, 4, it's relative to how many things are inside this list here. So it's just something to kind of be aware of. Now imagine our target was 1950. The numbers are going to be stuck at the very end. Let's count how many checks this does. So if we did checks is equal to 0 here, and what we'll do, we'll put this kind of above our if. We'll do checks plus equals 1, and let's just quickly do underneath. If you want to pause it here and try and guess what this will be my guest. But let's hit run. There we go, 136. Now let's try and add some more stuff in up front. Let's do, just for kind of argument's sake, let's add some more in. So 4 more numbers, and it's now at 210. So it doesn't scale horribly, but it scales in a way which isn't linear, right? Just by adding 1, 2, 3, 4 more things, we didn't suddenly go to 140 checks. We've gone to 210, and this will just keep growing. So again, not ideal, and I hope that kind of this demonstration shows why a brute force solution isn't a perfect solution in this case. I'm actually going to leave this here, and we're going to try the linear solution up next using our dictionary. For the efficient linear time solution, I've got a new set of numbers here and a target of 12. So with my target being 12, we're going to want, let's just write this down here, and we're going to want 5 and 7, and they are at 0, 1, 2, 3. So we're going to want to return 1 and 3 like this. Let's put that behind the hashtag. And I'm going to run through this in a bit of detail to show you kind of how this all works. And the crux of this is a dictionary. Now, there's a bit of a thing in Leetcode. You tend to find that, like, if you can use a set or a dictionary for something, it's always pretty good because it often implies that we're doing something in constant time. Now, a bit on that real quick. Using dictionaries or hash maps, the same thing really, just Python calls them dictionaries, or using a set, any lookup in a dictionary. So say, for example, you had a dictionary of 500 things and you wanted to access the key of X. That's done in what's called constant time. Effectively means, if you boil it down enough, instantaneously. Say, for example, you wanted to say, is 7 in this list? Same thing, you've got to kind of go dun dun dun, search down the whole thing. That's not instantaneous, that is not constant time. That's in proportion to how big this is. With a dictionary, doesn't matter. That's why dictionaries are so good to use. You can look up key values in effectively constant time instantaneously, and it's the usage of a dictionary in this which makes it so powerful. And without even kind of going into the algorithm to explain kind of how it works, all we're really doing is looping through these numbers. Okay, so we're going to go through 10, 5, 3, and rather than saying, okay, whilst at 10, go and check 5, 3, 7, 1, we're basically going to say, here's 10. Is the counterpart to this in the dictionary? And it's that, is the counterpart in the dictionary, which is instantaneous. If it is, cool, return it, no problem. If not, we're going to stick 10 in the dictionary and say, okay, now we're on to 5. Is the counterpart to 5 in the dictionary, which would equal the target? If yes, return. If not, go and add it. So that's basically the crux of what we're doing. So to go through the meat of it, let's move this up. We keep an empty dictionary. That's the start. Let's just call this, sorry, not very imaginative, let's call it storage. And we now have a single for loop. So we basically say, for each number in the list, and we do a bit of rearranging here to kind of make it work, we say, is the target minus the current number in the dictionary? If so, we're going to return it. If not, we're going to store it. So this dictionary basically acts as a way to say, okay, whilst looking at 7, the dictionary is going to keep hold of 10, 5, 3. So let's try and mimic this first, right? For each number in the list, so say we start with 10, right? Okay, we're on 10. Is the target minus the number in the dictionary? So basically saying, is 12 minus 10 in the dictionary? No, right now it's empty, so it can't be. So that means we're going to keep in our dictionary, let's see, we're going to keep 10 with its index. So imagine we store 10 with its index of 0 here. Okay, now we're on 5. Is the target minus number in the dictionary? So is 12 minus 5 in the dictionary? No, 7 is not in the dictionary. So store it. So in this case, we have 5. You're at an index of 1. Now we're at 3. In fact, tell you what, for speed, let's just imagine we're on to 7 next, okay? So we're on to 7. Is target minus number in the dictionary? So is 12 minus 7 in the dictionary? Well, yeah, 5 is here. Perfect. Cool. Return it. In this case, we'll return its value. So we'll return 5 and then we're done. That's it. That's how the linear time element of this algorithm works. So let's code it for real. And what you could do actually, for IDX, no, like that. There we go. For IDX value in enumerate, because I'm just doing a single for loop. I don't know, I prefer enumerate, but you could do range. It's up to you, really. I don't really mind. And then we'll do a colon, and then we'll print IDX and value here, just to sort of show you what we've got for the time being. There we go. There we go. See the previous prints as well. That's fine. There we are. So 0, 1, 2, 3, 4. Those are my indices, and we have all this stuff here good to go. So that's our first bit done for each number in the list. Now what we need to do is write this check. So is the target minus the current number in the dictionary? So let's remove, in fact, we'll do it in place of the print. So we'll say if the target minus the current number, so value, if you are in storage, okay, then let's just print, we'll print OK for the time being. Come on, VS Code, catch up. It keeps doing that underscore redline thing. I don't know, maybe it's my system being slow. So right now, nothing should happen, okay, because this check is going to be always false. I'm not actually adding anything in yet. But, okay, if this was going to happen in real time and it was all set up, this is where we'll be returning the actual pair. For the time being, I'm not going to do anything aside from the print for now, okay? I just want to show you kind of what happens under the else. So what we do is we do the following. We say else. We want to go to our storage dictionary. So we're basically doing this bottom bit here, store the number with its index. So we're going to keep value equals to index here. Now, this will add most things. It's not going to add everything because of this for the time being. But let me show you what storage looks like. It'll be quite important to see. Storage, and hit run, and there we go. So you can see the OK is fired. So yeah, there's going to be 1 we've not added. But we've got 10, 5, 3, and 1 there. No, do we? We have 10, 5, 3, and 1. Yeah, sorry. Yeah, we have 4 things inside our dictionary, and they have corresponding values of 0, 1, 2, and 4. So all that's left is to do something better with this print, okay? In practice, what you actually do with the Leetcode one is we return here, we don't do an else, and we just put this past the return. But just to get the concept down, this is fine. This is more than enough that you kind of really need to get. So let's print okay, and then what we'll do past this is print idx here. Just hit that a second, hit run. So we can see one of the pairs is at indices 3, and that's going to be 0, 1, 2, 3. That's going to be 7 here. What we need to do is retrieve the 5. The 5 exists in the dictionary, so what we do to do that is say go to storage, and then we do something actually quite fancy in here. If we did target minus value inside here, and run that again, we get 3 and 1 here. So this bit is kind of, it's almost like we're rearranging the equation here. So target minus value is going to be 12 minus whatever number we're on inside the loop here. And then we got 3, 1. There's a question that says it doesn't matter what order you return it, so it could be 1, 3 or 3, 1. So returning 3, 1 here is fine. All you want to do is just do it inside here. Where's the close one? There it is. Yeah, you want to return it inside a list like this here. Let's just tidy up and remove the bits we don't need. So we can get rid of the OK from here, get rid of the storage bit from the bottom, and we'll remove that line break there. And we'll run that again. There we go. Oh, actually, no. Turns out I didn't save it. There we go. Nice. 3 and 1. One more thing to do before we kind of suss this out. Let's zoom out ever so slightly. Let's go and grab this here and bring it down to this. And actually, what I want to do is bring that up here as well. We'll count the checks for the first one, 210. Okay, that's fine. And we'll do the same thing here, actually. We'll do checks equal to 0, and we'll put it, let's see, just above the if here. So checks plus equals 1, and print checks again. Okay, let's try that. 210 versus 21. So yeah, quite clear to see that this solution here is a whole lot better. I'll zoom in just a touch. But this, in my view, is one of the coolest things you sort of learn, especially with Leetcode. It's not just about solving problems and learning how to solve specific problems. This, in my view, is the perfect problem because you kind of learn this initial brute force stepping stone. You then learn a lot about, even though the code is logically correct and it works, you learn a lot about complexity and how to solve things in better ways. In this case, we're just using another built-in data structure, the dictionary or hash map, and utilizing the fact that this operates in constant time, and just using that to our advantage by saying, do the check, but if the check didn't work, make use of like the current iteration, store that so we can check it later on. So it's pretty straightforward. I think this took me, I can't remember now, I did this many, many years ago. When I first learned this, I was kind of really blown away by the fact that we could do this in linear time and just make use of a simple built-in like a dictionary. If you have any Leetcode problems of your own that you think are particularly helpful, or if you have an ideal or even better solution to this, feel free to ping us a comment. But if not, I'll see you all in the next video and have a great weekend.